Well, thank you, Dave, and thanks for having me back. So I know that this is a DevOps meetup, and the way I've couched the discussion is in terms of the CI/CD pipeline and how standardizing the CI/CD pipeline can lead to tremendous benefits. One of which is using ML to continuously tune cloud workloads. As a case in point, I've used one of our customers who is Ancestry, and we'll get into some of the details at the end of it. Feel free to ask me questions either about Ancestry. I'll answer them so far as I can. It's either details that I could not reveal or that I may not know. So that would be the extent of my knowledge, or about the stack and what we do at Opsani. I'll be glad to answer that. And as Dave mentioned, it's basically how did Ancestry use AI and ML for continuous autonomous cloud optimization, and why does that matter? That will become pretty obvious a little bit into the presentation. So going forward, first talk about what is continuous optimization as a service. This is something that we do at Opsani. So just to set the background, we leverage AI, or basically machine learning, to continuously and autonomously adjust workload parameters. So we detect what the workload is doing, what its needs are in terms of CPU, memory, other tunable parameters, and then based on the workload profile, we adjust the workload for cloud workloads. We adjust the configurations for the cloud workloads to improve performance, reliability, and efficiency of the cloud workload, which means it runs better, it generates fewer errors, and it generally costs less. And some of our customers that we've been lucky enough to serve are, of course, Ancestry, who we're going to cover today, but Intuit, PayPal, and Adobe are also on the list. Not surprisingly, all of these are companies that are moving to cloud native space pretty quickly. If you're in the DevOps space, this is going to be particularly relevant for you, and hopefully you can take the content of this meetup and be able to leverage for your day-to-day business. So a word about Ancestry and what Ancestry does. They have 3 million paying customers, and they have here more than, it says 20 billion records. They're actually pretty close to 30 billion records at this point. These are all genomics related data, so they're harvested from DNA or National Archives or family tree information to know who's related to what, and to be able to trace ancestry. That information can be used for drug discovery, for disease probabilities, and so forth. Now, they are a pretty innovative company, and they've moved all their operations at large scale to the cloud, and they've implemented CI/CD process to facilitate rapid software feature rollout. That sounds great. So this is where the problem is. They have this plan that they rolled out, and there were some hiccups. This becomes relevant to you as DevOps practitioners. And so here they were hard pressed to get the best efficiency and performance. So now here we're foreshadowing what the problem is, that despite rolling to the cloud and rolling out CI/CD pipeline, they had problems getting to the cost targets that they were originally projecting. They thought that it was going to be much more cost efficient, much more better to have the AWS backend instead of their own data centers. It turned out that initially that wasn't the case, and we will understand why that is. So they had lots of data information, petabytes of data, and that creates a lot of slush in the system, and it makes efficiency losses, especially when you have disparate teams going on. So this is what you're seeing here is what I call the digital transformation paradox. So let's understand what this paradox is. The first question is, why do we do the public cloud? And the reason is that we don't have to pay for these lumpy expenditures for the CapEx that comes for building out a new data center or buying racks of equipment and refreshing them every 4 years. It's a pay-as-you-go OpEx model that as you consume, you pay. In theory, that sounds great. And the other thing is that the infrastructure is now programmable. It's great for DevOps. The APIs make it so you can request more services, CPU, disk, computation, network, whatever it is. It's easy and fast. And basically, what the public cloud model has done is that it optimized infrastructure for consumption. We can consume quite easily. So far, so good. Now, the next question is, why do we go cloud native? And fundamentally, that comes down to increasing business agility. You want your business to move faster. You want to outpace your competition in feature rollouts and continue to please your customers. This is why you have technologies like GitOps and Kubernetes that makes deploying code and orchestrating that code much faster. If you go with containers, you eliminate a lot of underlay dependencies. So you don't have to worry about what version of Linux necessarily you're on. The container architecture should take care of that. And you can scale up and scale down quite easily. Again, that's wonderful. So now what we've done with cloud native solution, we've optimized app time to market. So not only can we get the app to the market faster, we have a consumable infrastructure that's just an API call away, and we can just get our API going as well. And the question becomes, why is the app underperforming, over provision, and costing so much? That's really the Ancestry problem. I have this app going out in the market quickly. I can consume infrastructure. Theoretically, that should be the best of both worlds. And the answer is, well, we are moving so fast in our DevOps motion, in our CI/CD pipeline, that we don't have time to optimize. And because the infrastructure is consumable, it's just an API call away. When performance sucks, you just consume more resources. Jeff Bezos is happier. He's the richest man, partly because it's so easy to consume his resources in service of rolling out software faster. So there has to be an answer to put the cost back in, the cost concern back in within the envelope, within the performance window that you want. And so let me show you what kind of the current state of the art is when it's in a CI/CD pipeline. Now we start with pre-prod, and you have some product owner, the pointed head boss. He has curly hair and kind of a couple of horns coming out of his head, and he says, I want a particular product or particular feature out. And when the statement is made, then the developers get going pretty quickly. Luckily, we live in a GitOps world, and with GitOps, you download code really fast. That code could be internal to the company. It could be internal libraries, internal services that somebody else has written, or it could be a bunch of open source stuff. You don't care. You just want to glue the functionality together as fast as possible and write as little new code as possible in order to get the code out. And that's what developers do. Then the DevOps team comes in. They build it, they test it, they integrate it with the various corporate systems, whether it's identity systems or ERP systems or financial systems, whatever they are. And the SRE team now takes it from the dev environment, smokes test it in pre-prod, and things seem to be working fine. And production, they go and everybody does this high five, it's live, kind of do the Borat thing, like, yes, high five, except that's when the performance issues become visible. Why did that happen? Is because, we moved really fast. The pointed-headed guy to the left wanted things done really quickly, and we pushed out everything quickly, and effectively we're using the customer as guinea pigs for doing beta test and performance testing. And at that point, you put the A team onto the product, and you say, okay, we need to do some real user monitoring, understand what the users are doing, understanding where they're suffering. Let's pump some synthetic load in there to understand where the choke points are and where the critical bottlenecks are. And then, gosh, I'm going to buy some really expensive APM licenses to stick in my network to have visibility and traceability to where my problems are. Now, my A team got repurposed from developing code to understanding what the problems are. In the meanwhile, I have a burning bush problem, meaning that the customers are screaming at me. I've rolled out a product, but it doesn't work all that well. So what do? I over provision. Back to the API nature of the infrastructure of cloud. Things suck, so I'm just going to consume more of it in order to get around the problem. That is the kind of the state of the art that happens. And now let's talk about the Ancestry and what Ancestry did with the CI/CD rollout. Now I call it the CI/CD woes to wows. They had some problems, but they made some really hard decisions in order to go from troubles, woes, to something fantastic, which is the wows. So initially, when they rolled out their CI/CD pipeline, they had a bunch of discrete teams, and they're adopting new processes and like canary deployments. Each team was doing their own thing, and there was no global coordination of what to do. So the company as a whole couldn't scale fast. Maybe a team could do things wonderfully, but that team didn't necessarily integrate with the rest of the company. So despite having cloud infrastructure, despite having gone with the DevOps movement and having deployed CI/CD pipeline, there was nothing standard. Everybody had their own CI/CD pipeline. And as a result, it was near impossible to govern for costs, for availability, for productivity. And the guys that were owner of the applications and owner of the infrastructure were kind of pulling their hair out trying to figure out how to solve this problem. And the issue also was kind of the approach. They had these messy old pipelines, and I'm thinking like when I say messy old pipeline, I'm thinking like one of the tar sands pipelines. It was built on Jenkins, and every team again had their own pipelines, and there wasn't a whole lot of continuous integration. In most cases, source code was being changed directly on the main trunk, and so they would kind of rely on this old school large deployments, not these incremental changes, and things were much slower than they should have been. But that wasn't across the board. There were a few teams that had the best practices. They could release code a lot faster. They would make changes in a branch and then check the deltas in. It was much more efficient for those. But again, nothing standard. That's old messy pipelines. And as a result, basically, some teams could release new products or new services or updates quickly within a couple of weeks. And I can't talk about most teams, but it was significantly longer. So 2 weeks is kind of like the benchmark for excellence at the time when they were on Jenkins. But teams, when we talk about old school software, you can kind of imagine what that would be like. It's significantly longer than 2 weeks, a different time unit. And and when you multiply this across the 40 systems that the company had, it was quite large. And you couldn't do like a company-wide sprint. Things took a while. So roughly 70 teams, 10 systems per team on average, which now it was a big problem. Now the question became, what is it? This is kind of where they moved to when they went to the cloud and to CI/CD pipeline. The question then becomes, how do you fix this problem? But let me kind of put this into context. We talked about the state of the art, and here Ancestry started out with their digital transformation, thinking it's going to be great, but it's like everybody's got one, like an opinion, something else. It's bespoke, it's broken. Everybody does things their own way. Oh my God, what do we do? So here, Ancestry made a deliberate decision. Basically, they said, and this takes a lot of guts. This takes top level support and sponsorship in the company, up to the CEO. Basically, they said, look, everybody stop. We're not going to release any more software until we standardize. And it's basically the reason we have this comparing canaries is like every time you want to deploy a new service, you would have to deploy a canary. They said, instead of deploying a new service or a new canary, why don't we all standardize on the same system? So instead of having a bunch of various pipelines and Jenkins infrastructure, they went to harness, they modernized. And in the process, they got a lot of great benefits. So, I talked about commitment, stopping development, and getting everybody to migrate to a common CI/CD platform. And, that was a brave decision, but the impact wasn't as great as it was feared because it was no different than rolling out a new canary release. Some teams could do it quickly. Some other teams were much slower. So it would have been painful. But in the long term, doing that stop and making that change created significant benefits. One of the significant benefits is having a standardized infrastructure, which if you want to roll out a global change, it's now easy. You can kind of roll out a service, put it in use for everybody, and everybody goes up. The net results are better productivity, better efficiency, less headache, more happiness. This is where things were. So now back to this picture. Now, we went from a bespoke system where everybody has one to like there's only one, which is the enterprise gold standard. Things were looking better. Except there is kind of a haunting problem. The haunting problem is kind of a fallacy. And the fallacy is that when I look at my cost, my performance, and my reliability in cloud for cloud services, they're going to be mutually exclusive. There's a good reason for coming to this. One of them is when biases is kind of created by the CAP theorem, where you can't have consistency, availability, or partitioning. You can't have all three. You can have two over three. So when people think about in terms of cost, performance, and reliability for a cloud service, they're going to say, well, I got to give somewhere. I'm going to have either crappy software or crappy performance, or going to be really expensive. So boss, you can't have it all. What do you want? And this is a fallacy, but this fallacy is in part driven by the complexity of modern applications. Before we get to the complexity, let me show you how this complexity is addressed. Back to the pipeline. Now we are state of the art. We have over provisioned because we're trying to address the customer's needs, but the costs are going up. Nobody's really happy. The SREs are getting calls at 3 a.m. The DevOps team is going nuts. So what do? You do some manual ops, some guesswork, and say like the system's way over provisioned. Let me figure out sort of what the configuration is, and let me try tweak a few things. And manually, I'm going to feed this back to the DevOps team and ask them to update the configuration in order to have better results. And the phone stops ringing at 3 a.m. The pager stops going off. Things appear to be better, but you really have guessed at what it is. And with enough experience, you get good enough information that you can get a decent config file, and the development team can actually test it and roll it out properly. This process takes 1 to 2 years, believe it or not, by the time that you have a decent config environment, and it assumes that the software, at the core of the software, is pretty stable. If there's a major change, this whole process repeats again. So this is how bad things are, but there's a real reason for this. And to understand the real reason for why we do this, let's understand the complexity of the modern service-oriented or microservice-oriented architectures. Here I use a case study, which is the Google Online Boutique. It used to be called the Hipster Store. You can see the diagram here. It's a collection of 11 different services that are connected to each other via APIs. You can update each one of these services asynchronously, which is great. The design is there so software releases can happen much faster. Now, let's take that we have these 11 different services. So stay with me, 11 different services, and we're going to tune two different parameters per service. We're going to tune CPU and memory for these 11 different services. Together, we have 22. 2 times 11, we have 22 services. And as I'm trying to gauge how to tune these services, I'm going to step through my CPU settings 8 times. So I'm going to go, let's say, from quarter CPU to 2 CPUs, and I'm going to do the same thing with my memory. I'm going to go for a quarter gig to 2 gigs, and I'm going to try all these different permutations to see what works. It turns out that that's a really large computation space. The number is 8 to the power of 22. It's I don't know if you remember Avogadro's number from high school chemistry. It was like 6 to the power of 23 or something. It's a really large number. And in this case, it's roughly 75 quintillion. And I just out of kick, I did a Google search for how many grains of sand are on Earth. It turns out to be 7.5 quintillion. So this is roughly 1 order of magnitude larger. The number of permutations that you can explore in order to optimize this basic online boutique is 1 order of magnitude larger than the total number of grains of sand on Earth per Google. So the human mind can't wrap itself around the size of a problem. It's too large. You have to have a new technique, and this is where ML becomes a viable method. And this is why having kind of a standardized technique across the company where you can plug in different services like Opsani's ML becomes a good way to do this. Now, again, just to kind of put things in context, all the grains of sand is 1 order of magnitude smaller than the total combinations in the Hipster Store that you can test in order to optimize. And believe it or not, I've had a customer ask me with a straight face, why can't I use kind of a brute force binary search to go through all this method? When he said that, I kind of did one of these and scratched my head. And the answer, is, when you're dealing with these numbers, when you're dealing with 75 quintillion permutations, let's assume that you took 10 microseconds per permutation to run through the 75 quintillion combinations, it will take you 23 trillion years. Um, you know, the only problem is that sun supernovas in about 5 billion. So we run out of time. Binary search using our current computation capabilities will not get us there. So we have to have a different technique. So coming back to what Ancestry did, they took the brave step of making sure that their pipelines and their tools are standardized. They picked harness and they rolled it across the entire company. And one of the benefits, of course, is, as you see, is now the company has a standardized infrastructure. Adding steps into the infrastructure and the pipelines are quite easy. So I apologize, someone got cut off. But basically, rolling out new services becomes much, much easier. So what does that mean in context of this conversation and the context of machine learning, tuning, and its impact to the company? So we have this pipeline that we discussed above, which is you over provision, you do manual ops, and then eventually get reactive build. Or you can do what Ancestry did, which you have exactly the same pipeline. And you deploy a service like Opsani at runtime. So in production, basically we take a tuning pod, which is a canary build basically, and we start experimenting on that and comparing the results versus what the actual workloads are doing. And the ML algorithm is not particularly smart. I mean, it's not human smart. It just uses statistical methods to figure out which parts of that 75 quintillion computation space it can eliminate with certainty and start honing in on the problem. And using this technique, you can find the right configuration for the parameters much more rapidly and produce results much more easily. So that's one place you can deploy it. The other place is you can shift left and you can actually put it as part of a QA stop. And every time developer puts out a new code, as in your CI pipeline, well, you can optimize that and then understand what the config file should be, and you can check that back into your repository and it becomes part of your history. So by the time you are ready to ship, you've already done that optimization and it's done for you automatically. And this is what we mean by continuous and autonomous optimization, is humans no longer have to think about it. The developer doesn't have to guess what the config file ought to look like. ML will take care of it for the developer. So the net result, I contend, is that it leads to higher performance and lower cost, and it actually offloads developers from doing kind of a grunt work of trying to figure out where things are and where they ought to be. And just in comparison, Dave mentioned that there's the ESXi logo. I was the PM that shipped VMware ESXi, and our hypervisor came out. Every major release took about 2 years to put out, and we literally had a team of 12 PhDs from Stanford that did nothing but tuning the stack. They had 2 years to tune this stack, and it was 12 very highly qualified people. Now we're moving to an environment where instead of releasing every 2 years, we're trying to release weekly, if not daily. And the question becomes, how do we increase the velocity of our tuning? Well, ML becomes the only way that you can do this. So looking at the net results for Ancestry, and these are the numbers that I'm authorized to put out, basically using the techniques that we help them deploy across the company, the production cost came down 23%, and performance efficiency, that means the number of transactions that we're able to get done per dollar went up 230%. So not only did the cost come down, but the throughput went up. So therefore, the efficiency is higher than just a mere cost reduction. And that was a huge win for us and for Ancestry, and we're really proud of this outcome. I want to come back to the Google Hipster store and focus on what we can do for this. Again, 75 quintillion issues. Now here, or quintillion different permutations. Let me talk about how long it takes and what we can do for this particular application, so you get a sense of why ML is desirable. The setup time is about 20 minutes if you're going in cold. It takes about 2 days of tuning, and the net results are, the number of transactions per dollar from the base configuration that you can get out of GitHub to the tuning that we do is about 8x. So you get 8 times as many transactions for every dollar that you spend. And that's because the cost has gone down by roughly 80%. The throughput goes up by 171%. Again, lower cost, higher performance, generally lower error rates. And the results basically speak for themselves. Not a whole lot of time to set up. It's a service. It gets rolled out across the entire company. So if you're in the DevOps motion, this is one of the tools that you can standardize across the enterprise, like Ancestry and Adobe, PayPal, and Intuit have done, and roll it across the company-wide and improve performance and happiness for customers and make your CFO happy at the same time because you're spending fewer dollars. And what the platform looks like is as follows. You have your Kubernetes cluster. You have the various namespaces where your products or your products or services are being developed. It takes a tuning pod. That tuning pod is basically a canary instance. The reason we call it a tuning pod is because not everybody understands what a canary instance is. It's basically using the load balancer, we siphon off a small portion of the traffic for us to run our experiments in. The service itself is SaaS, so you basically send out some minor performance data that's not identifiable, and in comes back in some recommended configurations that the servo then implements within the Kubernetes environment. Fairly easy to set up, and quite easy to run, and once you set it, it sort of takes care of itself. One of the common places where we see this as useful is with Nginx as an ingress. The good thing is that Nginx itself generates a lot of red metrics. So red standing for the response rate, the error rate, and D is for delay or latency. So using the red metrics from the Nginx load balancer, we can, and Nginx, by the way, exports that very nicely to Prometheus. We can tune the cloud workload that's sitting behind the Nginx ingress points. And this is the experiment that we ran with F5 recently, F5, having acquired Nginx. We ran it across 3 different variations. And one was with the open source, upstream open source, where the cost dropped by 44%, but the Nginx Plus, their paid product, because it has better load balancing, we were able to show better results. Now here you see that there's Nginx Plus via Envoy, so we didn't rely on Prometheus for metrics, we relied on our sidecar to get the metrics. And in the second case, we used native Kubernetes constructs. You see a delta of roughly 10%. Here we ran at our P50 response time ran more slowly. That's because the sidecar creates an extra computation and ingress or transaction layer that slows things down. Whereas if you go directly with a Kubernetes construct, your throughput actually does go up. So for P50 latency for the workload that we were optimizing, in this case the workload was a Bank of Anthos, another Google benchmark, we were able to produce these results. We're also partners with an APM company. Lo and behold, APM works pretty good for legacy applications, but we're helping the APM vendor, in this case AppDynamic, become cloud native ready. And APM at that point becomes our metrics source. So same architecture, you have an ingress point going to a Kubernetes cluster. We have our servo, which is a container that runs alongside your workloads, gets information from the metrics, and using that metrics, we make operations, and we make adjustments, and I'll explain how that works in a slide or two, actually in this slide. So the way we work is that we depend on a service level objective. How well should the application do? That's either prescribed by you, the customer, or if it's not, it's auto-discovered. Our auto-discovery is pretty simple. We look at a P90 metric, and that becomes the SLO level that we try to maintain. Here in the application namespace, we need a production pod replica. That's our control for the experiment. And we need a tuning instance. This is where we run our experiments. And we have our stats service up in the cloud. So what we do is feed the SLO, the goal, the objective, to an instance in our cloud service. And the cloud service blindly, it doesn't know what the software is, but basically says, let me give you some configuration tuning parameters to the tuning instance and see how that behaves compared to production. And as time goes on, it understands what tuning parameters matter more, whereas what does not. And in some ways, it actually produces counterintuitive results. We've seen the algorithm produce, when we're working with EC2 instances, not in this Kubernetes, but with EC2 instances, it recommended fewer instances, but larger. And that was counterintuitive. You would think that having a larger fleet of smaller would allow you to have a higher throughput. But for one of our customers, in this case it was Intuit, larger VMs, but fewer of them produce far better results. And we run on any infrastructure, and basically what the service does is it tunes a single service based on the algorithm that I just mentioned. It also provides instance count tuning. So if you need 3, if you need 5 or 7, whatever it is, and using the periodicity of the application, there could be some sort of cyclic behavior of load. We also proactively scale up and downscale the application. We don't wait for HPA to tell us that the CPU is overutilized, therefore roll out new stuff. That's a lagging indicator. We use historical metric to upscale and downscale applications, and that leads to better performance and lower cost, part of our juice. And then finally, you see the load profile adaptive tuning. That's basically if you have a workload that may be transaction heavy during the day and database heavy during the night, we shift the resources so it can do that particular workload, part of that application better. So not one size fits all. Database transactions typically take a lot of memory. Transactions take a lot of CPU. So that's how we shift resources in order to make sure that the application is doing what it should be with the least amount of resources while giving the best performance. And there are a bunch of plugins that we have, including Datadog, Prometheus, Wavefront, and plugging into various pipelines. So that's kind of the theory of how things work. If you're interested, I'll be glad to run through a demo, but let me pause over here and see if there are any questions.
Okay, so far we have one question, which is more around the security of the data that you're processing. So like when you have access to all this information, she says, I took an Ancestry test. How is my DNA data protected in these pipelines? Which you can apply to pretty much any company. So how do you deal with that issue?
Right, we actually do not, we don't look at any database information. All we're looking at is configuration information. So we look at the amount of CPU and the amount of memory or any kind of configuration data that you have provided, typically in a YAML file. So what your DNA information is in Ancestry is not available to us. It should not be available to us. And in fact, it wouldn't matter for our goal. What matters is how resources are being consumed in a YAML file, and therefore how we can best tune that application. So it's minimal set of data. It's actually quite lightweight. It's transported over HTTPS. So there's a TLS handshake that makes sure that data encryption happens. What comes back based on performance data, basically we say, okay, CPU utilization is this, throughput information is that. It's basically red metrics and few system information that goes to our system. We push back config data, and the configuration is adjust CPU this way, adjust memory this way, adjust other resources like your Java garbage heap that way. And that gets fed to the tuning instance. Experiment goes on, and again, we just collect system metrics, nothing about user data or system data. In fact, we don't even collect IP addresses or MAC addresses. It's all about what is the utilization red metrics.
So is that based on like Kubernetes namespaces, or I'm not sure what the right word is there, but like pod names and all that kind of stuff? Is that how it's categorizing things? Is it not pod? That's the.
So, going back to this, let's go back to the right diagram here. So when we are operating within a particular namespace, this particular namespace has a service level objective. So we may decide that it has to have a latency of 100 milliseconds, and we want to have so many transactions per second. So that becomes the SLO that we chase. In pursuit of that SLO, we look at what data Prometheus is giving us. So how many transactions do I have, and what is the latency for each transaction? That's all we care about. And from there, then we look at what we have available to us in a YAML file, and the YAML file says how much CPU memory and what other resources that we can adjust. But CPU and memory are the ones that tend to move the needle the most. So therefore, we adjust the YAML file, we start the containers, read the new YAML file, reconfigure themselves, and that's how the tuning pod starts performing with a new configuration, and we compare that against what production is doing. And when we know after typically 60 experiments or so, we get to the optimal state, and that's when we recommend promotion from the canary into tuning instance, into the production. Sorry.
I see. Okay, that's interesting. Yeah, so you're just looking at the metric data around the instances. You're not really looking at the data inside the instances or anything like that.
Correct.
Okay. Okay. Let's see. We don't have any other questions here, but I just wanted to kind of summarize a couple things here. So you mentioned that memory and CPU were where you get the biggest bang for your buck. And you also mentioned obviously instances.
Mm-hmm.
Where does that? So is your system making the recommendation and then passing that off to Kubernetes, which is then making the auto scaling choices? Is it simple like that?
So what happens? That's an excellent question. You're asking when we've determined what the right configuration is, how does it get promoted into production?
Right.
Right. So let me go to the right slide. Let's see. That would be this slide. Sorry. So part of our integration is with a CI/CD pipeline. So when we have the configuration that we're satisfied, and we measure satisfaction based on that, any incremental experiment that we do doesn't move the needle too far to the left or to the right, that we know we've kind of reached the maximum. And by the way, for anybody who is a math geek, we have ways of testing against local maxima versus global maxima. So we try to find the global maxima. But anyway, when we find what the right configuration is, at that point, our service has an option. One option is, let me check in the configuration file into the repository, typically GitHub. And so that becomes an available file that the DevOps team can use to deploy with the next service. Or when the trust is built up, as Ancestry has built up with us, then it becomes auto-deployed, which means that because we're now in Kubernetes world and stateless, we basically promote the new configuration automatically in harness in this case. The workloads the containers get started one by one sequentially. They pick up the new configuration file and they run with the new configuration. So that's the autonomous portion of our solution where we run. Basically, the machine takes care of AI/ML takes care of the configuration and pushes those changes automatically upstream. And because of stateless nature of the containers, you can restart them and just grab the new goodies and run better, more optimally.
Okay, got it. And as you said before, it's sort of a trust thing. Once the company feels that they understand what's happening and they feel confident it will work for them, they can take advantage of that automation.
Right. As it turns out, one of the best features you can have in a product is when you don't break things.
Yeah, absolutely. Okay, very good. Now, what do you call this space? Does this have like a category name to it?
Yeah, Gartner calls this AI ops, but AI ops is a bit overloaded. We call it continuous optimization as a service, COAS. Gartner puts continuous optimization as a service in a broad umbrella of AI ops. It takes them typically 3 or 4 years to break it down. And I think you will see some analyst reports coming out later this year in October where they have more granular. It's more granular in terms of how they define the space.
Okay, and one other thing is your service that offers this, is it a service or is it a product like software?
It's a service. So there is a component that you deploy on premise. You see, there was I've alluded to Servo. Servo is a container that runs in the namespace of the Kubernetes application or service that you're running. It's open source. You can look at it. It's really lightweight. Its job is to collect metrics, send them to our SaaS, and the SaaS ML chews on it, and produces new configuration, and gives it back to that particular instance of Servo, and Servo then implements that. So the only downloadable part is, it's a very tiny container that does something quite limited.
Right, and then what it's sending out to your SaaS environment is metrics that are not specific to any users or anything like that. So that's a reasonable thing to provide.
Right. In fact, no IP or any workload identifiable thing. All we need to know is how to reach our servo, and we don't care what's behind it.
Got it. Okay. Well, somehow we've picked up a few more attendees, by the way, which is kind of fun. So people stayed, and then we got a few more.
Typically they'll be here for beer and pizza. I don't know what you do in a virtual space.
Yeah, I'm kind of looking forward to that again. But yeah, but nobody's asking any additional questions. So I'll give you folks a couple seconds here. If you want to ask any other questions, go ahead. And yeah, the ML or / AI ops space, I guess it's now AI ops, right? Like you wouldn't say ML ops anymore. Those kind of mean the same thing. You might as well just say AI ops, right? Is that
AI ops? Yeah.
Yeah. Okay. Yeah, it's a huge space. I'm seeing so many different companies recruiting for tech talent in that kind of category, or that plus security. Okay. Well, good. I think we'll let you wrap it up. Is there anything you want to share about upcoming events or anything that we should be looking for coming up soon?
Well, it's so. Thanks for that opportunity, but it so happens that that I've been immunized, and hopefully you have been too, taking your vaccine. Because it's time to get out in the real world.
Yep.
I think our next event when we'll be public it's going to be KubeCon in October in Los Angeles. So hopefully everybody will be able to come down there. And when Kubernetes came out, it was really exciting. It was the first workable large-scale container orchestration model that made cloud computing possible. I think that's just the beginning, by the way, where cloud computing is going. It's at some point there'll be whatever serverless means, but it's going to be, people will not even have to worry about the substrate of orchestration. You just check in code, and a lot of different services will take care of it. And a Fargate is a step in the right direction. But in any case, back to your question, we will be at KubeCon, and it would be wonderful if anybody wants to come stop by our booth, or if you want to reach me, and if I can answer any questions, you can reach me at Amir, AMIR, at Opsani.com. I'll be glad to answer any questions. I'd love email. I don't get enough of it, so I need more.
Oh, yeah, I know. I've kind of switched over to Slack so much. My email inbox is pretty slow, too. By the way, I missed this. There is a question from Parag Kale. He asks, can this help in vertical scaling of infrastructure, not just the application?
Vertical, the answer is yes, but it's a qualified yes. Typically, like the reason I've been harping on Kubernetes and containers is because it's a common pattern, and from a go-to-market perspective, it's easy for us to attach to Kubernetes and roll out. I mentioned Intuit and resizing their infrastructure, their EC2 workloads. So our ML engine doesn't care what the software does. Where it becomes more difficult is integration with the infrastructure, because every infrastructure has its own quirks and dependencies. So it becomes more professional services heavy. So the theoretical answer is yes, but just like in theory, the difference between theory and practice is that it's a lot smaller in practice than it is in theory. And here it's like, yes, it's theoretically possible, but professional services get in the way, and we prefer not to do infrastructure scaling.
Got it. Yeah, I can understand that. Interesting. Yeah, I have seen folks in the observability space, which is clearly related to what you guys are doing. The fact that you have a relationship with App Dynamics is kind of hinting at that. But I've seen some folks actually enter the observability space through infrastructure, which, as you said before, it seems like a heavy lift. But hey, if they can do it, then great, I guess. And then they'll also do the application observability too. So I don't know, maybe there's something there. Who knows?
But Dave, one really cool example is like if you go to Target and swipe your credit card, between swipe and that receipt coming out is less than a second. It's just so fast. But go to like another store like Nordstrom's, and then they have a salesperson whose job is to entertain you while you're waiting for that receipt to come out. And if you have this high volume business like Target, optimizing your infrastructure and applications really comes down to like how many customers you can put through that cash register and how fast you can generate revenue. It's really dollars and cents. It makes good business sense to invest in APM for older infrastructures or into optimization for newer infrastructures. It scales up the business significantly.
Yeah, that makes sense too. Good. Okay. Well, believe it or not, we are already up against an hour, which I just surprised myself looking at the clock there, noticing that it's gone, went by fast. So why don't we go ahead and wrap it up? And I guess one last thing is, if folks want to find out more about Opsani, obviously they can go to opsani.com. Is that the URL?
Yeah.
And is there anything in particular, like about on the website, about like maybe upcoming webinars or anything that you guys are doing there that they should be looking out for?
I think I used to have that job. I think I don't anymore. But it's what I would suggest is that you throw your name in the hat, and webinars will be coming up. In fact, we will have one coming up with App Dynamics and another one coming up with F5, two of our partners, in the next short while. So if you want to register on our website, we will spam you.
All right. Great. All right, Amir. Well, thanks very much. And everyone, thanks for attending. We'll wrap it up now, and want to hope that you'll continue to join us in these talks. We are heading into summer. We'll probably just do no more than about one per month during the summer. But come check us out, and we look forward to seeing you again. So, all right, Amir, and feel free to let us know what you guys are up to, and we'll perhaps hear from you again sometime.
Thank you so much. And Dave, thank you for the opportunity.
You're very welcome. All righty. It's real quick. Somebody wants the PowerPoints or get your email. Maybe they can email you. Would you? What's your email address?
Email is Amir, AMIR, at Opsani.com.
There you go. Okay, great. All right. Thanks a lot, Amir. Take care.
Thank you. Bye-bye.
All right. Bye, everyone.